In this video, we're going to look at methods for solving a system of equations. And we're going to look at pretty much all the methods that are taught in a regular college algebra class. So we're looking at, in this case, we're going to look at two equations with two unknowns. You can have two equations with two unknowns, three equations with three unknowns, four equations with four unknowns, and so forth. If you have more variables than you have equations, then generally you're going to have either no solution or an infinite solution set. But if you look at just an equation in two variables by itself, it has many solutions. You can find many values for x and y that will satisfy the first equation. For example, if I pick x to be 0, then the 3x term cancels and I get 2y is equal to 1, so y would be 1/2. And that's one solution. You put a 1/2 where the y is. 1/2 times 2 is 1, 0 times 3 is 0, we get 1, and 0 is 1. But that's not going to work in the second equation. So you can find many numbers also for the second equation that work. You just plug in a number for x, solve for y, or plug in a number for y, solve for x, and you get a solution to that equation. But if it's a system, it has to satisfy both equations. So the first one represents a line. So the lines could be parallel. So they could go something like that. And again, these don't look parallel, but let's assume that they are. Parallel means they don't intersect. So that would be the scenario where you have no solution. Now, if you were to graph the two lines that represent those two equations, and they intersect at one point, that's going to give you one solution. So you get one value for x, one value for y. In other words, you get an ordered pair for a solution. Now, if it turns out that the two lines coincide, then you have an infinite solution. So I just want to illustrate that for you right now in an example. So let's look at x minus y is equal to 1, and minus x plus y equal to 2. If I were to graph these two lines, again, I'm going to have one of three scenarios. They're either going to be parallel, which means they're going to have no solution. They're going to intersect at one point, which means we'll have one solution. Or they'll coincide and they'll have an infinite solution. So when you have a system of equations in two variables, what you want to do is we're going to look at the elimination method, which is this one right here. This is the first one. We're going to solve this same problem using different methods. So in the elimination method, you're using properties of equality. That means allows you to add two equations together or multiply both sides of one equation or both equations, add them up, try to eliminate one of the variables, and then solve for the other variable. And then you just plug into one of the equations to get the second variable. Now in this case, if I add these two equations, okay, I'm allowed to add them. This equals to this, and then this is equal to this. I can add this to this, and this to this, on this. Both sides, I should have equality. But notice, x minus x gives me 0. Minus y plus y gives me 0. So the left side rather is just 0. 1 and 2 is 3. That's a contradiction. 0 cannot equal 3. So in that case, you have no solution. Basically, the lines are parallel when you graph them. There's no solution. Okay, clear this. Now let's suppose I have x plus y is equal to 2. And then say I have the second equation is 2x plus 2y equal to 4. Okay, the objective when you have a system of two equations with two variables is to again multiply one equation or both by some number. So when you add them, you want at least one of the numbers to one of the variables to cancel, either the x or the y. We can solve equations with one variable. Right? 2x equal to 4, no problem, we just divide. If I have 2x equal to 4, we can solve equations with just one variable. Just in this case, it's 2 into 4 gives me 2, so that one's no problem, x is equal to 2. But if you have two variables, it causes problems. So in this case, what I'm going to do say, okay, this is a 2x here, and this is a 1x here. Let's make that a minus 2, so when I add a minus 2 and 2 would cancel. So let's do this, minus 2. I'm multiplying everything in that first equation by minus 2. So minus 2 times x is a minus 2x, and a minus 2 times y is a minus 2y. And a minus 2 times 2 is a minus 4. But if I add those up, minus 2x and 2x is 0. Minus 2y and 2y is 0. And then minus 2 times 2 is minus 4, and 4 is 0. Now in this case I don't get a contradiction. I get a true statement. But I don't know what x and y is, because they canceled. So when you get a situation like this is simply telling you that the lines coincide. So you have an infinite solution set. So basically you can say, you can represent one solution by just solving the equation for y or for x. So when I had x plus y here, you can use either equation because basically it's the same equation. One is just a multiple of the other one. So in this case, just solve for y. You get y is equal to 2 minus x. Solve for one variable in terms of the other one, and then you can just say x is any number. And that's basically your solution right here. It's an infinite solution. So you want to know what are some solutions. You can just say, okay, pick any number for x. Let x be 0. What's y? 2 minus 0 is 2. Okay, pick another value for x. Say 1. If x is 1, what is y? We'll put a 1 there. 2 minus 1 is 1. Those work. 0 and 2 is equal to 2. 1 and 1 is equal to 2. So this, but you would represent the solution in a formula. You say, okay, x can be any number, y will equal to 2 minus x, and then if you want different solutions, you just plug a value for x. So those are the three types that you have. In this case, we're gonna concentrate on the different methods. Okay, so you want to solve this equation by the method indicated. So for the first part here, it's solving this equation by elimination. Okay, so what I want is I want to add the two equations so that either the x or the y cancels. Doesn't matter which one you eliminate. So here we have a 3, here we have a -2, here we have a 2 for this one, and a 1 here. I think it's easy to cancel or eliminate the y. So you can rewrite it if you want, but I'm just going to leave it and just multiply. So the first one I'm going to leave it 3x plus 2y is equal to 1. And then I'm going to say, okay, minus 2 times a minus 2 is a 4x, and a 3x is a 7x. And then minus 2 times 1 here, and the second equation is minus 2y and a minus 2y. Those cancel. And then now the next one, minus 2 times 4 here, and the 1 stays, and I'll multiply. In some cases, you'll have to multiply both in order to do the cancellation. So you work out the best way possible, the easiest short method to use. So minus 2 times 8 is 4, rather, is minus 8, and 1 is minus 7. And then now, we did this in another video where you have it in this format. You just divide the 7 into the minus 7, or divide both sides by -7, by 7 rather. So you get x is equal to -1. Now, once you've gotten the first value of, in this case, x, you can either eliminate the x, or you can just plug in a -1 where the x is. So notice here, if I put a -1 where the x is right there, that's a +2. So plug it in negative. It doesn't matter which one you use. So plug in -1 into the second equation. I get -2, and where the x is, I put -1 plus y is equal to 4. Okay, so now we have an equation with one variable, y. So -2 and -1 is +2 equal to 4. Okay, using the shortcut methods I went over in the previous video. We want to isolate the y, so just take the 2 over. It becomes a minus 2. 4 minus 2 is 2. So my solution is x equal to negative 1, y equal to 2. Sometimes I'll write it as an ordered pair because it really represents a point. This is actually where the two lines, if you were to graph these on a coordinate system, this is where the two lines intersect, negative 1 and 2. And you can see, you can easily check it. Negative 1 there with the x is for the first one, negative 3. Y there is 2. That'd be 2 times 2 is 4. Minus 3 and 4 is 1. Checks. Minus 1 times minus 2 is 2. And a 2, that's 4. That checks. Now, you can get the value of y by elimination. Here I got the value of x by eliminating the y, and then I plugged in. But you could have done it this way and said, let's cancel the x. So in order to do that, when I add them, these have to be opposite. Remember, here multiplied by negative 2 is 2 and negative 2. So let's do this. Multiply this one by 2 and this one by 3. So a 2 times a 3 is 6, and 3 times a negative 2 is a negative 6. 6 and negative 6 would cancel. So I could do it that way, and then 2 times 2y is 4, and then 3 times 1y is 3, 4y and 3y is 7y. And then for this one here, then 3 times 4 is 12, and then 2 times 1 is 2, 12 and 2 is 14. Y equal to 2. Okay, same thing we got in the other one. Now, we got the x already, right? Using the same method, so either way we get x equal to negative 1 and y equal to 2. We could have, if you had done this first to begin with, then you would have plugged in the 2 where the y is, put a 2 there, and the second one, subtract it from this side, 4 minus 2 is 2, and then divide by negative 2, we get negative 1. Still works out. For the next one, substitution. Substitution. It's the same equation. So in the substitution method, basically what you do is you solve the equation for x or for y, whatever's easier. So to solve for x here, I'd have to bring the 2y over and divide by 3. Here, the coefficient of the y is a 1, so I'm going to choose that one. Let's solve the second equation for y. So I want y on one side. So leave the y there and then take this over. Remember, it just changes the sign. So it's going to be 2x plus 4. Now, remember the object here is you have two variables. You want to eliminate one of them. You want the equation with just one variable. It can be the x, it can be the y. It doesn't matter. So now I solved the second equation for y. This is what I got. So now I go to the first equation, and where I have a y, I replace it by this. So I've got 3x plus 2y. So I put a 2 there, and then put parentheses here. That's the y, and that's going to be replaced by 2x plus 4. And that's going to equal to 1. Now you have an equation that just has one variable. So we solve that equation for x. We combine terms. So we say, okay, this is 3x. Got parentheses, so we multiply through, plus 2 times 2 is 4x. 2 times 4 is 8. We get this. And then now combine terms on each side, whatever you can. So we've got 3x and a 4x. I got that 7x. And then the 8, have to isolate the variable. So we want the x's on one side. The 8, we take it over and you change the sign. So it's 1 minus 8. Negative 7. Okay. Easy shortcut from the last video. 7 into -7 is -1. So x is -1. And then go to the one we use for substitution. This is already solved for y, so put a -1 right there. -1 times 2 is -2, and 4 is 2. So y equals to 2. Or you can say this is your solution right here. Or you can write it as an ordered pair, because that's what it is. That's where the two lines intersect. -1 and 2. So that's the substitution method. And again, if I'm going too fast, you want to see the video again, just pause the video and rewind. The next one, using matrices. Using matrices. So here I'm assuming that you know what a matrix is, but a matrix is just a collection of numbers arranged in m rows and n columns. So it says row echelon method, the Gauss-Jordan method, matrix equation method. So there's a bunch of methods using matrices. But here's what happens. The way I'm going to do it for you, we're going to use what is called an augmented matrix. So I'm going to use, basically, you always want the equation to be in simplest form. When you're solving systems, you want the variables on one side ordered like this. So you want the x, the y, x and the y, and then the numbers on the other side. Now there's going to be times where you have 3 variables, so x, y, z, x, y, z, x, y, z on each equation. Or you can have some that are missing. Maybe one of them has the x and the y, maybe the other one has just 2, x and y, or x and z. But you just order them in the appropriate way. And if there's any fractions involved, just pure the fractions. Always want to simplify an equation. So if you have fractions, just like I did in some of the other examples, the last video, is multiply through by the lowest common denominator, and that gets rid of your fractions. And then you just start this particular technique here. So here's what we do. We're going to write down what is called the augmented matrix. Okay, so I'm going to put brackets. Usually when you deal with matrices, you use brackets. So in the first row, I'm going to use this coefficients. So a 3 there, a 2, then a -2, and a 1. And then a bar here, and then on the right side, next column here will be the constant on the right. So it's 1, 4, 1 and 4. And what we're doing here with matrices is you're basically using the same operations that you use with systems. You're allowed to multiply your row by a non-zero number. You don't want to multiply by 0, but any non-zero number, and you can add it to another row. Okay, just like with equations. You can multiply one equation by a number, add it to a second equation, or vice versa. Or multiply both by a number, and then add them. Now, we want to simplify it as much as possible. So what I'm going to do here is I'm going to try to get some zeros here. Okay, simplify this a little bit. So here's what I'm going to do. I'm going to add the second row to the first one. Okay, so -2 and 3 is 1. 1 and 2 is 3. 4 and 1 is 5. Okay, and then for now I'm going to leave the second row the way it is. -2, 1, 4. See, that's the equivalent of multiplying the first equation by a number and adding to the second, or multiplying the second equation by a number. In this case, it's the second row, so the second equation is multiplied by something and added. Okay, so then I get this. So all I did here is added the second row to the first. And that's what I got. Now, on the next one, I'm going to leave the first row the way it is. Then now I'm going to make this minus 2 a 0. So how can I make that into a 0? Just that's so the equivalence of just eliminating one variable x here. So I'm going to multiply the second row by 2, just mentally, and add to the second. So 2 times 1 is 2, added to the negative 2, this is a 0. 2 times 3 is 6, and 1, that's a 7. And then 2 times 5 is 10, and 4 is 14. So again, I multiply the first row by 2 all the way across and add it to the second. So 2 times 1 is 2, and minus 2 gives me 0. 2 times 6 is 3 is 6, and 1 is 7. And then 2 times 5 is 10, and 4 gives me 14. Okay. Now I could continue with this, and this one right here. The first matrix is called the augmented matrix of the system. Just taking the system and write it into a matrix. And look, this is just saying 0x plus 7y is equal to 14, or that's just telling you that 7y is equal to 14. Well, if 7y is equal to 14, y has to be 2. Okay. Now, in the top row, this is still the same. This is just saying 1x plus 3y is equal to 5. So let's just do this. Now let's go back to the equation. The 1 is a coefficient of the x. The 3 is a coefficient of the y. But the y is now 2. So this is 3 times 2 is equal to 5. So solve that for x. So 3 times 2 is 6. Subtract it from the other side over here. 5 minus 6 is negative 1. Okay, you get the same thing. X is equal to negative 1. Y is equal to 2. Or it's the ordered pair negative 1, 2. Now there's other methods. Let's say solve using matrices. Well, I use matrices here. But you could also use another method, which is the Gauss-Jordan method. You can use the matrix equation method. But this satisfies it because it says using matrices. Let's clear this. Now, associated with every square matrix, okay, any matrix that has the same number of rows as columns has a number associated with it, which is called a determinant. Okay, so the next method says solve this method using Cramers Rule. So Cramers Rule basically tells you this. Okay, same system again. I have the system 3x plus 2y is equal to 1 minus 2x plus y is equal to 4. What it tells you is you form a determinant using the coefficients of the variables and the constants over here. So you form a determinant D. Notice the D. The first components, the first column of D is simply the coefficients of the x, 3 and negative 2. And then the second column is the coefficients of the y, 2 and 1. Now if you have a system with 3 equations and 3 unknowns, you'll have a determinant with 3 rows, 3 columns. Now, notice the next determinant, I call it d sub x. It's the same thing as the first one. Notice the same thing as the first one, except the first column is replaced by these constants on the right, 1, 4. 1, 4. The determinant I'm calling d sub y, this is according to Cramers Rule. Notice the first column is still the same, but because it's a y here, the y column gets replaced by these constants. 1, 4. Cramers Rule basically tells you that the value of x is going to be whatever you get for d sub x divided by d. Y will equal to the value of d sub y divided by d. Now, this is under the condition that d cannot be 0. If d is equal to 0, then we're going to have either no solution or an infinite solution set. And we could do that. We could solve those types of problems using the first couple of methods, substitution or elimination. But how do we evaluate a determinant? basically we just cross multiply here and here, and then subtract. So basically it's 3 times 1, so here's the way it works. 3 times 1, subtract, and then this product, negative 2 times 2. So 3 times 1 is 3, and this is minus, and then minus make that a plus. So that's going to 2 times 2 is 4. So d sub x is 7. I'm sorry, d is 7. Now, d sub x, we do the same sort of thing. Cross multiply here. So 1 times 1 is 1 minus this product, 4 times 2. That's 8. 1 minus 8 is negative 7. So this is negative 7. Now, d sub y, again, for the 2 by 2s, it's easy to evaluate. You don't need a calculator or go through a lot of detailed calculations, because I can just cross multiply. 3 times 4 is 12. And it's always subtract here. And then this cross product here. 1 times a negative 2 is a negative 2. Minus makes it a plus. So this becomes 12 plus 2. That's 14. So you do that. Now, if you're dealing with a system of 3 equations with 3 unknowns, then you're going to have a 3 by 3 determinant. 3 rows, 3 columns. But the ones with just 2 variables, they're pretty straightforward. So on this one here, then you simply say this is equal to, okay, d sub x. If it's x, it'll be d sub x over d. If it's y, it'll be d sub y over d. If you have a third variable, z, okay, that'll be d sub z divided by d. You have to do evaluating 3 by 3. But in this particular case here, then d sub x is negative 7. Look at that. D is 7. Negative 7 divided by 7, that's negative 1. Okay, so x is equal to negative 1. That's what we got using the other methods. And then d sub y is 14. And of course d again is 7. 14 divided by 7 equals to 2. So again, we get the same solution. Using the matrices, using the elimination, using the substitution, and of course using Cramers Rule. Now again, I've gone over, I've done a lot of videos in my channel dealing with solving systems using different methods. I cover determinants and so forth. So this is just an overview of the methods that you can have. I point out to you that if you have a system of 3 equations, with 3 unknowns, then your first series of steps is going to be to take the first equation and the second equation and eliminate the one of the variables. Usually it'll be the same on both. So you take the first 2 equations, eliminate, say, the z, and then take the second equation, the third equation, and eliminate the z from that one using elimination method. And that'll give you an equation with 2 variables, x and y. And then you just follow this method. You get values for, you get the answer for x and y, and then you just plug into any one of the first 3, and you get z. But anyway, if you have questions or you want to see more detailed examples, please leave a comment after the description. Of course, the other methods, sometimes your instructor won't let you use a graphing calculator, but there are ways you can solve a system of equation. I've done some videos with the TI-84 calculator. I've also done some with the TI-89. So this one, you can refer to those videos if you're interested in that. But I hope this gives you some information that you can use, and we'll see you next time. Thanks for watching.